Welcome to this manual video for the Hero demo included in the Action Adventure Kit by SoftLightner. This video and the accompanying manual pages were made to explain how the major parts of the demo work and how they use the core framework. We will start off by going over the Hero Setup prefab, which contains the player character and all the UI. Afterwards, we will explore the individual scenes and their contents. The top game object starts off with a couple components related to persistence. Persistence container is the main persistence component that manages all the current data. The player pref saver is used by the container to load and save its data to Unity player prefs. When the debug field on the saver is checked, it uses temporary variables instead. The data in debug data then deactivates intros and starts the inventory off with a sword and shield. The random state persister makes sure that random drops like items from pots are consistent between sessions. The playtime persister saves the current playtime, which is then displayed in the intro scene when selecting the save game. The state manager manages the general state of gameplay. The play and menu states are triggered by input events on the player input component on HeroCharacter. The cutscene state is, for example, triggered by a state override in the Hero Intro Beach timeline. Check out the events of the manager to see all the actions it performs when states are changed. This object contains the main camera and Cinemachine brain, as well as a couple different virtual cameras. The free look and first-person objects are used by the lockable camera. The present camera is switched to within the Hero present timeline when new items are shown. It points at the present target within the character model in front and above the character. The flash and hurt cameras have a timeline that very shortly switches to them, resulting in red and white flashes of the screen. They are triggered by flash and hurt messages on the character. Hurt is sent from the HeroCharacter state machine when damage occurs. Flash is sent on start by a script machine in the Hero Nut Impact. The Hero player character script contains some custom Hero demo logic in addition to the base character functionality it inherits from the core character class. This includes presenting new items and sheathing the items the character has in its hands. It also forwards confirmation and cancel presses to text boxes. If you check its events in the inspector, you should find some actions that forward messages to the audio manager. Most of the custom logic of the character is defined in the HeroCharacter state machine. When the main state manager is not in its play state, the character state machine moves from its gameplay to its paused state and also sets the timescale of the entire game to 0. It also takes care of forwarding animation parameters from movement, triggering idle animations, choosing and triggering context and attack actions, responding to damage and death. The character controller and character controller movement manage the character's movement. The movement speed is set to 0 because in this demo movement is driven by the root motion of the animations. Player input is a part of the new input system in Unity. It is configured to invoke Unity events here so you can find the various actions that are driven by input by expanding the events field. HeroKid is where the visuals of the player are located. It contains the animator along with an animator proxy that passes along events and root motion from the animator to the character. The following steps show how the player model could be replaced by the skeleton model that is usually used by the enemies. Some other components of the demo depend on the player model, so those have to be moved over or reassigned. Open up the Hero Setup prefab. Drag the model's character's Hero Skeleton zombie into HeroCharacter. Assign the HeroKid controller to the controller of the animator. Select the old HeroKid object and drag over the animator proxy and animator parameter setter. Fully expand both models, you will see some additional transforms in HeroKid. Drag over the extra transforms into the same spaces in the skeleton. FPS position in head. Sword sheath, shield sheath, and overhead item in chest. Various transforms in root. Delete the HeroKid model. On the hero player character, set animator to hero skeleton. Set item, parent right left to the new item transforms. On character controller, movement set, pivot to hero skeleton. In the lockable camera, free look, in camera replace the reference transform and set all the renderers from the skeleton to first person hide renderers. If you now open up Hero Debug General, you should be able to move around and perform all the different actions with the new model. Trigger contains a capsule collider trigger and a rigid body. These are used by a trigger damage receiver for damage that affects the player, and a generic trigger item for general trigger areas like the ExitTrunks. Actor contains actions the player can perform on its own, and the actor that manages their execution. The hero demo uses the minimal character actor, so the character can only perform one action at a time. Jump is a basic motion action that propels the character when it is started. Roll is also a motion action, but it locks rotation movement while active. The different attack actions use visual scripting action. Open up the hero attack action graph to explore how it works. The messages it receives are sent by animation events found in the HeroKid model. Guard is a custom action made for the hero demo. It was made in code as it performs some bone rotations that would be a hassle in visual scripting. The starting and ending events are configured to send messages that are used in the audio manager. Sheath is a simple visual scripting action that prompts the character to sheath items it has in its hands. The sheathing itself is handled in the hero player character. Present is a timeline action that executes a timeline that shows off a newly gotten item. It gets started by the hero player character, which also instantiates the visual of the item. Die is another timeline action that is started from the hero character visual graph. Climb is a custom action that lets the player climb up some special surfaces. Double-click the script to check it out in Visual Studio. It has an explanation at the top of the file. Examples for climbable surfaces are found in Hero Debug Climbing or the Hero Beach and Hero Inland scenes. The inventory uses a simple listed inventory and contains no items in the prefab. Items can be added for debugging in all scenes except the beach scene. As this is the first scene that is loaded, the inventory content there determines the player's starting items. In any other scene, there should already be saved data that overrides the inventory content set in the scene. The inventory also defines some item capacities. These are raised when the player collects a capacity-raising item like the nut bag or money pouch. There is no place to collect these in the regular game yet, but they can be tested in Hero Debug General. Both sword and shield slot are of type instantiating item slot. The shield and sword parent transforms they instantiate into are moved to the character's hand or sheathing position by the hero player character script. The equipment slots use a fairly simple custom slot called Hero Equipment Slot, which instantiates the action prefab defined on the hero equipment item. The instance of that action is then checked to determine if the slot can be used. The 3 regular slots are used from the equipment buttons that are visualized in the top right. The 4th slot, called Equipment X, is used when an item is used directly from the menu. This object contains a couple different components representing the character's status. There is only a single resource value in the resource pool called health. It is decreased by hero health damage and increased by usable items like the hero heart. The hero character state machine initiates death when it runs out. The attribute pool contains the hero heart's attribute, which is increased by collecting hero heart essence usable items. The hero heart's maximum stat copies that attribute and is used to determine the maximum health of the hero. This is configured in the resource maximums field of the pool. There is an effect pool even though there are currently no effects relevant to the player character. The currently only effect of the demo is called Hero Stun effect, and is added to enemies when their Hero Stun resource is filled by the Hero Stun damage done in Hero Nut Impact. You can quickly try that out in the Hero Debugging Skeleton scene. LockOn contains a trigger collider and a LockOn manager, which is a special kind of trigger area. It receives inputs from events in the player input component on HeroCharacter. Enemies and anything else that needs locking on have to contain the counterpart LockOn point. There are some simple spheres with LockOn points to quickly try this out in the Hero Debugging General scene. The Hero Target Candidate has a follower component that is triggered by actions configured in the Manager's Inspector. It visualizes possible lock-on points while nothing is locked on. It also contains an animator that is controlled by events on the follower. Another follower can be found on the lock-on target in the UI transform. This one is shown when a point is actually locked on. There is a separate testing scene for the lock-on system in Adventure Core .tests called LockOn Test, which can be used to test out the system in isolation. The Audio Manager contains sound effects directly related to the player character. Its key field is empty, making it the main manager accessible anywhere. All messages received on the hero player character are forwarded to it using the Message Received event. This includes messages sent by animations using the onAnimation function. You can find these on the HeroKid Model import. For example, select HeroKid Role and expand the event section to find step messages, along with the start and end messages needed by the action. Some messages are also handled by items. For example, the S-Swing message on the HeroKid Attack HHA animation is handled by a character messenger directly on the Hero Debug Sword prefab, allowing different sounds per sword. Some messages are also sent by actions directly. Jump and roll, send a grunt message when they are started. UI is the root transform for the 2D user interface of the Hero demo, which is made using Unity UGUI. As such, it contains the typical canvas and event system components, as well as the input system UI input module, which connects it to the new Unity input system. The only AAK component here is the event system cursor, which places the cursor element over the current game object of the event system and scales it to fit. The sign dialog is used by the visual scripting action in the hero sign object. Has to be assigned in the variables of the script machine of the sign so it can display its text. The text box TMP is used to display newly acquired items as part of the present timeline action. The one located in text box full screen is used in the die action. Menu contains the pause menu with its gear, equipment, and settings tabs. Showing the menu and tabbing between screens is handled by the Hero menu script. It references the fade transform, which contains a solid black screen that is used to fade out the screen when the game is ended. The top bar contains buttons that can jump directly to their tabs and buttons that switch to the right and left. The actual contents of the tabs are located in the contents transform. This is where the player model that is shown in the gear screen is located. It uses its own camera and lighting, which is separated from the regular game by using the UI layer. The contents of the sword and shield slots from the actual player character are copied using instantiating item slot clone scripts. The Gear tab shows some general item info and lets players select their current gear. Character shows the fake character model located in Gear. Items contains different buttons that use the Hero Gear toggle script to equip and unequip gear items. Heart Shards visualizes how many Hero Heart Shard items the player currently carries using a visual script machine, since the shard is a placeholder item. When the player collects their fourth shard, a Hero Heart Essence is added instead, and the shards are reset. Keys uses a simple item quantity visualizer to visualize the current number of keys. In the Equipment tab, players can assign equipment items to their equipment slots. The actual assignment and animation is handled by the respective Hero slot panel in the HUD. These check which Hero Equipment button is currently selected to know which item to assign. Alternatively, equipment can be directly used from the menu by pressing the button. The Settings tab contains audio slider components for changing different audio group volumes and a quality dropdown, which changes the visual fidelity to one of the quality settings defined in the project settings. It also has buttons for ending the game that trigger methods inside the hero menu. The HUD shows the player health, money, and available actions during gameplay. Different situations like cutscenes or dialogues require parts or the entirety of the HUD to be hidden. This is done using a state manager that activates game objects and passes animator parameters according to the current state. Since it's not possible in Unity to call methods with multiple parameters from events, the manager uses an animator parameter setter to set the state parameter of the animator. Equipment 1 to 3 use the hero slot panel script to display the currently assigned item and for assignment of the slot from the equipment tab. Money has an item quantity text-capped script, which visualizes the quantity in a text field and changes its color when the item capacity is reached. Health displays the current and maximum player health using one hero health bar script, which has references to a hero health unit for each possible heart. Money and health are both stored as prefabs, so they can be reused to display money and health of the save slots in the intro screen. The title screen lets players select game slots to create new games or continue games they have started previously. The background of the screen is made using a Cinemachine dolly cart that runs on a looping Cinemachine smooth path. The general flow of the title screen is controlled from the state machine found on the logic transform. It goes through the following states. Black sprite fully blanks out screen. Fade out black sprite to reveal the background. Fade in the logo sprite. Wait for confirmation. Fade out the logo sprite and fade in the saves canvas. Wait for game selection. Fade in black sprite. Load scene stored in scene variable by hero save slot. Save slots are found in UI saves contents and use the hero save slot prefab. They each have a minimal character setup, including a persistence container and generic character, which loads data from the configured save index. The prefabs displaying health and money use that to load their data. You can check the data of each save slot from the editor using the Edit Save Data Debug button in the inspector of the container. The behavior of each slot is defined in the hero save slot visual script. When it starts, it checks whether the persistence container already has any data and shows the new game or load objects accordingly. When a game is started or loaded, the script sets the save slot application variable, which is used by the containers in the actual game scenes to retrieve the current index. It then sets the scene variable to the current scene of the save game or hero beach for new games and triggers the start event on the logic object, which transitions that state machine and ultimately loads the game scene. Every game keeps 2 persisted strings that dictate where the player currently is. The string stored under scene simply contains the name of the scene that should be loaded. The string and parameter is meant to store how the scene should be entered. For example, a number representing the entry point. Hero Beach is the game scene players enter when they first start a game. It plays a short intro cutscene that shows the player character waking up and then hand control over to them. Over the course of the stage, players climb a cliff to collect a sword and shield. The sword then lets them cut through some vines that block the path to the next stage. A heart shard is hidden in an optional little cave that is also blocked by vines. When the scene is loaded, a couple different things can happen. This is configured in the script machine in the entry object. It checks if the intro has already been played using the beach intro persisted bool. If it has not, it starts the timeline action in intro. Otherwise, it checks the string persisted under parameter. If a 1 is found, it starts the hero enter subgraph that moves the player in through the trunk, leading to the inland scene. Otherwise, it starts the hero wake timeline action, which quickly fades the screen in from black. This usually happens if the player has died. All the environments in the hero demo were made using Pro Builder. They use the same hero default material as all the object and character models that were made externally using Blender. To assign colors to individual surfaces, the UVs of those surfaces have been collapsed together and moved to the wanted color in the Pro Builder UV editor. The cliff part of the environment has been split into its own mesh. The game object has a mesh collider and generic trigger items, so it can be detected by the generic trigger area of the hero climb action located in the player actor inside the hero setup prefab. The collider has some depth, resulting in a semi-pyramid kind of shape, as flat surfaces result in some problems with how climbing works. Chests in the hero demo use the custom hero chest action, which extends the common timeline action. When it is started, it moves the character to an exact spot in front of the chest defined in the object character target, and when it ends, it adds items to the character as defined in the items field. It also saves whether it has already been opened to the persister. When the game starts, and that persister is already set, it moves the chest animator to its open state and destroys itself so it can't be used again. It can be annoying to get both the chest and player model into place to test out the timeline in a regular scene. The hero debugging interaction scene contains a non-playable version of the player chest interaction that makes this easier. The forest transform contains an audio source with a looping track that contains some tweeting birds and general forest ambience. Its position and spatial parameters are set up so that the player only hears them as they get closer to the inland caves, and so they increase in volume as they move into them. In the opposite direction out in the water, there are 5 different transforms, Wave AE, for wave sounds. These are controlled by the script machine found in Waves. The machine waits for a random duration between 1 and 5 seconds, and then chooses one of the waves, varies its pitch, plays it, and repeats. Both the hero vines and hero sea urchins have colliders and a destructible damage receiver, which replaces them with their destroyed prefab when hit by any kind of damage. The hero vine's destroyed prefab simply contains a sound and some particles which all play automatically when it is spawned. It gets destroyed after 2 seconds by its Fade and Destroy script. Hero Sea Urchin pickup also contains a Hero Heart pickup, which uses a Hero Pickup Area to give a Hero Heart usable to any character that enters its area. The pickup sits under an animator which performs a little growing and floating animation. The entire object starts to blink after 10 seconds and then blinks for 3 before being destroyed as defined in the Fade and Destroy script in its root. The hero ExitTrunk found here is used to transition the player to the hero inland scene. The script machine in its root defines how it behaves. When the player enters its area, it sets the game state to cutscene, starts the exit timeline action, and transitions the sound to the muted snapshots. When that action is done, it sets scene and parameter to whatever is defined in the variables. In this case, the scene is hero inland, and parameter is 1, so the inland scene knows which entry the player is coming from. Finally, it saves the game and loads the next scene. In addition to the exit action, it also contains an enter action which is triggered by the entry if parameter is 1, meaning the player enters the beach coming from the inland trunk. An isolated version of this behavior with visible marching points and collision areas can be found in Hero Debugging Loading. Hero Inland is the second scene players encounter in the Hero demo. They reach it after leaving the beach through the trunk they find in a cave. It prominently features an entry to the temple scene, which is initially blocked by some rocks that can only be removed using a bomb. The bomb equipment item can be found in the canyon scene, which is entered through the second trunk, located on the right side of the one coming from the beach. Players can also find their second heart shard on a ledge to the left of the trunk. To get it, they have to defeat a skeleton that pops out of the ground when anyone gets too close. The entry in Hero Inland decides between 3 different parameter values. They result in the hero entering either from Hero Beach, Hero Canyon, or Hero Temple. The entry to the temple uses the Hero Exit Passage bomb prefab, which is a prefab variant of Hero Exit Passage, with the addition of a bombable cracked wall. Hero Exit Passage behaves pretty much identical to the Hero Exit Trunk exits we have already seen. It only differs in the models and timelines used, which animate the passage opening and closing with some particles and a sound effect. The Hero Cracked Wall is another destructible similar to the vines we have encountered previously. It can only be destroyed by bombs because hero bomb damage is set in its filter field, and bombs are the only damage sender with that kind of damage. When it is destroyed, the damage vector is applied as a force to all the rigid bodies in the Hero Cracked Wall destroyed instance. The strength of that force can be changed by adjusting the magnitude of the damage sender in Hero Bomb Impact. or by changing the push power multiplier in the damage receiver of the wall. Of course, changing the mass of the rigid bodies will also change how far they are propelled. Whether the cracked wall has been destroyed is persisted using a destruction persister. This kind of persister sets a bool when its game object gets destroyed. If it wakes up and that bool is already set, it immediately destroys itself. The behavior event trigger on the same transform activates the exit whenever the cracked wall is destroyed. This prevents players from unintentionally activating the exit area before actually cracking the wall. The pots around the entrance of the temple combine a couple things we have already seen. They can be destroyed by any kind of damage, like vines, and their destroyed prefab has separate rigid bodies for all the shards, resulting in a nice dynamic shattering effect like the cracked wall. Pots can also be picked up and thrown due to the hero carry action located on the action transform. It is available as a context action when its area collides with the player's character action area. The force applied when throwing can be changed in the power forward up fields. If the put allowed field is checked, the pot will be softly put down in front of the player when the throw button is pressed while the character is not moving. It is not used like this in example game scenes, but hero carry action could also be used for small plate puzzles. An example of this can be found in the Hero Debug General scene. Look for carry object and pressure plate. In addition to regular damage, pots are also destroyed when their rigid body receives a strong enough impulse, usually when they are thrown against something. This is configured in the maximum impulse field. How much that impulse affects the destroyed shards can be adjusted in impulse power. The hero pot pickup random is also a bit more advanced than the pickups we have seen on sea urchins previously. The hero pot pickup visual script chooses a random pickup from a number of different options. Some of the options, like bombs, are preconditioned by the character already having that item in their inventory. Otherwise, players could randomly find bombs in a pot before they actually get them in the canyon scene. These enemies use a basic generic character in combination with a navmesh agent movement to move them around. The actions they have available can be found under their actor. Skeletons are not visible at first because their animator starts them off in the buried animation. The skeleton stays underground until a character enters the generic trigger area found in the area object. While the player is inside that area, an animator float instruction is applied to it, as defined in the instructions field, setting the aggro animator variable to 1. This changes the stance of the hero while locked on and transitions its face to the mad animation. The HeroCharacter state machine also monitors that variable to change to combat music. Which actions the skeleton performs is driven by the hero skeleton script graph. Once a character enters their area, it sets that character as its movement target, starts the rise action, and activates its lock-on point. Whenever the current action of its actor changes to null, now it checks if it is close enough to punch the player, otherwise it runs towards them. The script machine also checks for damage. Whenever it receives a hit that does not kill it, it force starts the hit action, making it flinch. If the damage does reduce the health to 0, it replaces itself with hero skeleton destroyed. The Ragdoll visual scripting unit transfers all the transform positions to the destroyed model. The hero skeleton script accesses actions by their name. This can be done for any action that is a child of the main actor of the character. This saves us the hassle of keeping all the needed actions as visual scripting variables. In Hero Canyon, the player evades a rolling boulder to get to a chest containing the bomb equipment item. There is a cracked wall on the boulder's path that blocks the entrance to a little cave containing the third heart shard. During the intro cutscene, the boulder is deactivated until the camera pans over to it. This is only done to make timing it a bit easier. It is controlled by the custom Hero Boulder script, which moves it between the points defined in the points field. When it reaches one of those points, it fires the stopped event, and then waits for the corner delay. The boulder carries a trigger damage sender that basically damages the player if they touch the boulder. Its direction is set to sender to receiver XY, which causes the player to be pushed away from the boulder's center but into the ground or up into the sky. Whenever it hits something, it calls delay on the boulder script, which stops the IT and avoids just rolling over the player. Hero Temple is the currently final scene of the demo. Upon entering, the player is faced with 2 blocked-off passages and 1 open one. Entering that passage, they are locked in with a skeleton enemy. Upon defeating that enemy, they can collect a key item from a chest that lets them unlock one of the other rooms accessible from the center. There they move a block in order to reach another chest that contains the Sling equipment item. The final heart shard is hidden behind the block here. If this is the fourth heart shard players collect, they gain a heart essence, increasing their HP by 1 heart. The Sling lets players open the third room in the entrance by shooting the target above it. Behind it they find chests containing the superior knight versions of the sword and shield. The final room is another arena containing a bigger skeleton with increased health. The chest behind it contains a heart essence that increases their maximum health. The temple scene uses a couple different variants of the Hero Passage prefab. It is basically a door with an action for each side that moves the player to the other side. Check out the Hero Debugging Passage debug scene for various examples of passage setups, including one for the base prefab that just lets players walk through without any special behavior. The Hero Passage Arena variant adds a script machine to the passage which starts acting when the timeline action on the enter transform of side A ends. The script closes the bars and then activates the enemy. It shows these happening using the Hero Highlight subgraph, which activates Cinemachine cameras for a set duration. It then periodically checks if there are still enemies remaining. When they are all gone, it opens the bars back up and sets a persistence value. If that value is already set when the scene is started, the arena destroys itself, which lets the player walk through unhindered. Hero Passage Locked contains a simple visual scripting action that determines whether it can be started by checking the character's inventory for the hero key item. When it is started, it removes one key from the character's inventory and plays a short animation, after which it opens the passage up. It also sets a persistence key, which lets it know if it has already been opened if the scene is reloaded. The Hero Target visual script on Hero Passage Target attaches to the damaged event of a trigger damage receiver. When it is hit, it plays an animation which is highlighted by a virtual camera and then opens up the passage. It is also persisted very similarly to the other passages. The Hero Block lets player move it by using on of the Hero Block actions located at each side. For some other examples of using this prefab like falling down or activating a switch, check out the Hero Debugging Block debug scene. One notable difference in the activation of this action is that it ends once the button that activated it is released. This is detected using the context action release message, which is sent from the HeroCharacter state machine inside the setup prefab. Whether the character should push, pull, or stand still is determined by the input the action receives in onInput. The input is received from the move event in player input, which is configured to call on direction on the player character. The character then forwards it through its actor to the active action. Climbing also uses this input for its climbing direction. The iskinematic field on the rigid body is set to true unless the character is currently moving it, which may be a little counterintuitive. Having the rigid body kinematic unless it is grabbed is done, so characters don't move it just by running against it. Setting is to false while pushing is done, so the block can fall through holes in the floor under it. When the block starts falling, the action is ended and a coroutine is started that resets as kinematic once the block has stopped moving. The Hero Sling equipment item contains the custom Hero Sling action. It implements the eye-holdable interface, so it can put itself in the player character's hand when appropriate, and also lets it be put away in the same way the player puts away the sword. Depending on the auto first person, it can also activate first person, when the player is pulling back the sling without being locked onto a target. To try out how the sling interacts with other parts of the demo, check out the Hero Debug General debug scene, which starts the player off with a sling equipped in one of the slots. It also contains ammo pickups and a pebble pouch that increases the sling's ammo capacity. Hero Debug General features a wide variety of items and objects. The hero character starts with a filled inventory and equipped items. The white spheres in front of the destructible bushes contain lock-on points, which can be used to test out the lock-on system. The slightly larger sphere also contains a test action that can be started as a context action whenever it is locked on. This could theoretically be used to read signs from a distance or talk to NPCs sitting out of regular action area reach. The red blocks and spheres can be used to test out damage. The blocks have damages senders with different damage values, magnitudes, and directions. The red capsule also contains a minimal enemy setup. This includes the stun resource, so it can be used to test out the stunning nut equipment item. The opposite side has some items that can be carried. The pots spawn different pickups as defined in destroyed prefab. The bombs ignite as soon as they are picked up, which cannot be found in the regular stages. The cylindric black carry object can be placed on the pressure place in front of it, which can be detected in its trigger. Hero Debugging Loading can be used to test out and debug the entry logic that is defined in each scene, and the exit logic used by the Hero ExitTrunk and Hero Exit Passage objects. It features two different exits that both load back into Hero Debugging Loading. They set parameter to different values, which is then used in the entry visual script. The timelines used when entering and exiting use a march track that moves the character towards a configured transform. These transforms are visualized with white spheres here. The red box in the scene instantly kills the character, which lets us test out the die action and the entry scenario with an empty parameter. Hero Debugging Passage contains different variations of the Hero Passage prefab. Only Hero Exit Passage is more of a variation on the Hero ExitTrunk, but using the model from the passage. The root of the passage contains a state manager that is used to set a couple different objects active or inactive together. For example, if the Hero Passage locked variant detects that it has previously been unlocked, it sets the manager to the open state. Otherwise, we would have to separately deactivate both locks and activate the entry areas, which would all have to be exposed to the visual script. The interactions themselves use a timeline, action to open the passage, march the character through, and then close it again. It activates different virtual cameras that show the character entering and exiting. The hero reset signal is sent during the timeline, which resets the third-person camera to the camera position of the virtual camera. The passage variants used in the temple scene are described there. The inland scene contains a passage exit blocked by a cracked wall. Hero Debugging Skeleton can be used to quickly try out combat. It contains 3 skeletons that pop up when the player enters their area. The player starts out with equipped sword, shield, and equipment items. The skeleton itself is also described in the inland scene, where the player usually first encounters that enemy. Hero Debugging Block shows off a couple more things that could be done with the movable Hero Block object in addition to its usage in the temple scene. There is a regular block in front of the character which can be pushed or pulled in any direction. To their right is a block that is limited in its movement. The block behind the player can be pushed into a hole with a trigger which activates a red sphere here. The raised area to the character's left can be used to test how a block behaves when it falls through a hole. Hero Debugging Climbing contains a couple different ways to set up a climb trigger for the hero climb action. The wall to the character's left combines 3 separate colliders into one rigid body with a single trigger area. This allows us to have a hole in a wall using convex colliders. The climb action can only use one area at a time. Moving between areas mid-climb is not possible. In front of the character is a plateau that can be used to test out pulling up onto a higher level. It also has a damage sender for testing out damage while the character is climbing. The small platforms behind the player are climbable, but too small to actually climb on. This results in the character always immediately pulling itself up onto the platform. Hero Debugging Ground is made to test the ground checker located in the sound transform in Hero Setup. The check is triggered whenever the character receives a step message and should play a different sound for each of the ground colors in the scene.